what we could make now would be the linkage, the leg linkage and the arm linkage, and that's basically with some .01 brass stock, which of course I'll be providing. So in the case of the walking pin, the pin that makes the robot walk, got myself a piece of paper so that I don't forget. What you're going to try to achieve is, on one end you're going to need the eyelet, because it's going to connect to the motor gearbox to move things, and the other end we need to cut at the correct length so that the robots will work right. Both the walking rods have to be exactly the same, otherwise your robot's going to walk to the left or to the right or have a little bit of a limping problem. The length from the center of that hole to where we want to make our cut is going to be 3 5/8 at the longest. If you went 3.5 inches, that would work too. But you wouldn't want to go more than 3 5/8, or there wouldn't be any point ever where both feet, or any one of the feet, is completely sitting on the ground. In other words, the pin would always be sticking down. It'd always be a little teetery. So I have a diagram I can use here, but there's no reason a guy can't just use a ruler, right? You lay it on there and you go, okay, there's 3 5/8. You could make a mark with something like 3. There's 3.5. There's 3 5/8. Just like that. And again, if you've got your dikes, why do anything else? Just snip it. Again, a Dremel cutoff wheel would work great for that part too. You might as well make the other leg one, because again, you want to make sure they're both exactly the same, and there's no better way to do that than to literally hold 2 of them together. Then I normally take a file to the ends and file them till they're both the same length and they're not rough. So I can't do that and hold all this stuff, so let me shut this down for a second. Okay, I filed the ends so they're not so ragtag, and of course you have some adjustment here still. If you found you'd made something too short, you could work it out further, or if it was still a hair too long, you could push it in further because you got some room to move. But what we're going to need to do now that we have these both made and right is we need to solder the connector to the brass. And if you have a soldering pencil that's got enough heat to it, no problem doing this. But it's really a lot quicker if you've got like a little mini torch, and Lord knows you can buy the little mini torches everywhere, right? Every crack addict guy's got one, and so does every hobby store and every Home Depot type place. So I'm just going to go over and lay these on a brick so I don't burn anything. Hit them with the torch, hit them with a little bit of solder, you know, because here's the crack in the seam in the eyelets. I'll make sure that I flow some solder around that and around the brass, so I know they're all good and solid. Okay, there they are, all soldered up nice and pretty, as you can see. So there's our 2 walking linkage. Now we need to make the ones for moving the arms, and they're a little bit different in that there'll be an eyelet at both ends. So basically we need to cut 1 1/8 inch of brass rod. So using the ruler there. And we need to make 2 of them, of course. Like that. And the eyelets have to face opposite each other on this piece. Like that. Let me do it to the other one. Then we need to check the length from the center of the eyelet hole to the center of the eyelet hole. It needs to be 1 5/8. That one is. Should be real close if you're using the dollar store piece and the dimension of 1 1/8 for the rod. And there we go. So again, I got to go over and torch and solder those ends so these parts don't move. So I'll be right back. I'm back. And both soldered. And we need to put a bend in these because of the way the body gets narrower at the top, so everything will line up without binding too much. And I believe hold it with the flat side here. If I do it wrong, we'll just rebend it. It's just brass. Just put a little bend in it, and I just move my needle nose right down and put a little bend in it, and end up with a joggle. So down here at the legs, we're out further. The body's going in narrower, so that pulls that out a little to help keep things still lined up. If this part was used on the other side of the robot, yeah, the same bend technique would work on both sides. You think I would know that, wouldn't you? Well, I do, of course. The same bend technique we'll use on both sides. And there's the other one. So now we have our linkage built for walking and our linkage built for the arms. Okay, next we might as well put some of the linkage onto the motor gearbox. And basically there's a small plastic spacer. It's actually a cheap plastic bead that I cut in half, and then I supply with some 440 screws. So you'll grab, say, the leg linkage first, go through it like that, then grab one of the arm linkage units, and I believe it goes like that. Remember, the thing tapers in. Then we'll take one of the spacers, put that on there. The spacers to keep all these rods and stuff from hitting on that where the nut and where we cut the shaft. And we don't want to tighten this down all the way. We want to leave quite a bit of slop so that these don't bind, so we know that they can move freely. I'm not really sure when I'm in the camera. I'm kind of trying to peek as I'm talking here. So we'll do it again to this side. Take the screw, lay it into the leg one first. Then on the arm one, it's going to be the end furthest from the bend. Lay it into that, because the end that we bent is the end that connects up with the arm and not at the gearbox. It's no big deal. It's just like the other one. Screw the screw in as far as you can without making it tight. You want to leave things a little sloppy, a little loose, so that they can breathe and move around. If they dangle free, you're probably alright, huh? Since I had clipped off all the others, this is going to be the lobe that hits the switch for beeping a horn, which only happens once per step cycle. So what I want to have happen is at the same time as the horn is honking, I don't want the big grill light coming on, which draws, the light behind the grill coming on, because it draws a lot of current. So I'm going to cut off this lobe over on this other side like that, because obviously this thing turns around. If this is down hitting a switch, I don't want that one down hitting a switch. So this one can hit the switch 3 times. It can flash the grill light off and on, and the eyes alternately off and on. I'll show you how that works a little bit later. But the one time that it beeps, I would like to know that the grill light's off, because it draws almost 300 milliamps of power. Okay, so those are on. We know they're looking loose, they're looking good. What I would normally do at this point is take a small screwdriver and put a little bit of goop on the threads of the screws on these back sides, so there's no way the screw's going to work loose, or worse yet, work tight on its own and bind things up. And you don't really need to do that on camera, but it doesn't take but a second. Just scrape up a little bit of glue, hit it on the threads there. And the good thing again about the goop is if you need to take that apart, you can grab that stuff, because it's like rubber cement, and you can yank it out of there and you can still get the screw out, but it's not going to come out on its own, so it's pretty handy. Later, I mean, you could do it now if you wanted, but later we're going to be lubing some things up, and one of the places we'll put some lube will be in there, and on the brass gear. We won't put any lube on these. We don't need to do that for now.